Thank you so much all for those wonderful presentations of the problem statements and for the really good questions in the room. So we've got our 15-minute Q&A slot for the next session, and then we have one more problem statement here before we break for lunch. So I would, at first, if Simon is still here, invite him to join us on the panel. And if you do have a question for a speaker who's had to leave the room for another session, please do still ask them and we'll take them away, or you can connect during the breaks. But we do have the Slido open, for which the link is #Basecamp26, or would invite all questions from the room as a priority if you do have any that you haven't yet asked. Okay, if there's no immediate questions in the room, we'll pull up a few from Slido. So, question for you, Stephen. What data is available for this challenge?
So I think I kind of alluded to it earlier. We do have a regular maintenance and inspection schedule on our network, and I would imagine the other networks have similar processes. So I would anticipate drawing out that data to understand the asset condition. For example, that could be transformer tests, things like that, to understand the gas levels in the oil, those sorts of things. I'm assuming we would be willing to share that kind of data with a party once we're in contract, but that's kind of basic data that I was thinking of using.
Okay, wonderful. Thank you. Got a few questions in the room.
Yeah, so just a follow-up question to that. Xander Burbidge, Smith Institute. I guess wanted to know on that data what the nature is of missing data. I know from other conversations with SSEN transmission that not all assets are necessary, especially the older ones are very well mapped. And,
yes, that would be part of the challenge, certainly. Yeah, it's filling in the gaps. That's a good point.
Great, thank you.
It should be a quick one. Just wondering, you said it takes a long time to negotiate the ERTS. Yes. How long is a typical?
Well, we typically start at really getting into it a year ahead. So that's where the sort of 12 months came from in response to another question.
Okay.
But that can continue right up till weeks ahead if it's particularly contentious.
And how quick do you think that, what's the potential reduction from having this tool available?
I think we would still have the conversations that far ahead, but they would be shorter.
Yeah.
If there's a pre-agreed gradation of probability of risk and everyone's signed on to it and everyone's comfortable with it.
Okay.
Yeah.
So it more streamlines the process, enables you to do more in parallel.
Yes, exactly.
Hi there, Chris from LCP Data. There's a question for Jonathan on the islanding project. I think there's an SSEN project on resilience as a service. I think it has a lot in common with the challenge that you're talking about. I wonder if you could expand upon, what's additional to that, why it doesn't sort of meet the needs already of that project.
I probably have to take that one away. That's not, not being kind of close to it, in general terms.
Yeah,
I think,
thank you.
I think we mentioned certainly some of the projects that are relevant. I don't know if that was on there, but the problem has come from our system planning team, so they'll be, I'd be surprised if they weren't aware of that and any kind of links to that, but I can certainly take it away.
Jonathan Gale from NISO. I have a question, two questions, one about the islanding and one about the demand risk. So for the islanding, you're not talking about the island being a result of a transmission fault, you're talking about only planned scenarios?
Yeah. It's well, it would. The island would occur if to prevent the cascading of the fault, across the entire network. So you'd isolate. So it would be, to minimise the broader effect of a fault, at one point in the network. So to protect, key parts that that are considered where islanding is beneficial. Okay,
and for your demand security, Stephen, would you envision your solution to include more distribution data than transmission data? Because from a transmission point of view, usually you have two circuits feeding a GSP, but once you get to a GSP, there's a lot more network diversity going out into the distribution businesses.
Yeah, I would agree. We would really need the DNO to be a willing partner to share that data and help us identify any gaps in it. But yeah, I think the DNO data would be more pertinent to the solution than the transmission data, because there's probably more factors to consider. Yeah.
Okay, thank you.
Well, thank you. Do we have any more questions in the room?
Hi, Mark Collins, Smart Grid Solutions. This is a question for Jonathan. With the resilience, are you the sort of scenarios you're trying to cover? Is it across the board of dynamic stability as well as transient stability and time series coverage of control as well? So you're looking for a full solution as you go from fault state into general operation state?
Yeah, it would be both. I think, at this point, we're kind of, like I mentioned earlier, we're quite open to, any solution that, whether it's the transient or, more dynamic. But, yeah.
One final question. What would the sort of KPIs be for a solution? What sort of things would you be looking to ensure that the network is achieving?
I suppose looking at resilience levels compared to the network as a whole would be one. For each of the islands, which parts of the network, well, not so much a KPI, but which part of the network would benefit from islanding? But that would be kind of come from the modelling work, which would drop out some sort of resilience measure. But I think at this point it's
more of a general.
It's quite fluid, yeah.
There might also be an element of the ESRS compliance to think of, if you're familiar with that. It's the Electricity System Restoration Standard, which is a code change that I think becomes legally binding from December 2026. So that's a good measure if we're compliant with that.
Thank you.
So are you thinking of resilience in terms of measuring the system's resistance to faults untoward, transients and...
Yeah, it's more that, so in terms of compliance, there'll be some standard of compliance even in island and road. Right, yeah. So it's a case of visualizing those compliances. They might be different. Like it was mentioned that the regulations might be different. And it's a good point Stephen made there. But so it's making sure that when you are in those modes, you are considering the compliance that's expected for that situation.
Yeah, understood.
Well, thank you. Any more questions in the room? Any of our panelists? If not, we'll pick up a couple that have come in on Slido so far. For you, Simon, if a machine learning solution is utilised, would explainability be essential to ensure operator confidence?
I'll answer the question, but what I'll say at this stage is it's kind of not what I'm looking for at the moment. At the moment, I'm looking for, to solve some of the big challenges, should we be using AI? I think we should. And if so, should we be pooling resource and having a centre of excellence? And that might be one of the issues it looks at. So if you think about AI as a general term, right, and generative AI is a very specific thing within AI, but if we think about AI in general terms and we think about machine learning, fuzzy logic, generative AI, large language models, there is obviously a lot of skepticism. There's a lot of enthusiasm and a lot of skepticism, and some of the skepticism is around explainability. So it might be that when we set up a research centre, we look at not just the technology in solving the problem, but we look at challenges of how do we get to a place where we're confident we can adopt some of these things. I've absolutely no doubt that some of the players and some of the people involved in looking at how we use AI to manage the network will want security assurances. Is it secure? Can it be hacked? Can it be open to malfeasance? So the people developing the AI, putting in backdoors or kill switches, we've had all sorts of issues with looking at the political implications of some of our vendors and whether some of those vendors can put in kill switches. And I think the same thing applies to AI. So, but they might be the types of problems that a section of that centre of excellence looks at. So, and explainability is a big challenge in a lot of the innovations we do. So you get the same thing with robotics. There's a lot of resistance to robotics because people don't like robots. They just don't like them doing their jobs. And so AI is not just a technological problem, it's also a kind of human behavioural. How do you get people on board? How do you instill confidence? How do you know it's reliable? How do you know the answers it's coming out with is reliable? So it's part and parcel of that, but I'm not looking for a project on that at the moment within this because if I don't have a centre of excellence, I don't have anybody to work on that problem. Now, I could work on it on my own. That's fine. And it might be that I do know that, NISO have a pretty good AI program at the moment. They're making good progress and they're probably looking at that. So that there will be these things, some of those things are solved by individual people operating and some of those things need to be looked at in a coordinated, shared way.
Wonderful, thank you. Got a couple minutes left, so I'll try and get one more question in for Stephen and Jonathan. So Stephen, starting with you, talking about the probabilistic demand risk, how likely is this tool to be used with existing outage planning processes, and what do those processes currently look like?
I think they could. In terms of what they currently look like just now, the way we build up the year ahead plan is we collate the sequence of outages needed to deliver construction projects and asset replacement projects, and then we fit the maintenance outages around that. So the maintenance outages, we don't have so much of an issue with ERTS because the work's less invasive, so the ERTS can be lower most of the time, so they're not so contentious. So the focus is on the project outages, and that's where we focus the conversation around ERTS mitigation. There are deadlines in SDCP 11.1 outage planning that set out what outage information we need to provide to the ESO at what time through a year ahead process so that they can then go out and communicate that with the affected parties, including DNOs, and that's what triggers those deeper conversations once we get feedback from the DNOs via NISO. So if we had an agreed framework of risk for each GSP, I think it would make that feedback loop much faster or shorter and streamline the outage planning process and save time for everyone involved in that particular feedback loop.
Wonderful. Thank you, Stephen. And last question for Jonathan. So talking about the islanding project here, what are the key success factors that you have in mind for this? For example, customer minutes lost, voltage stability, frequency maintained, etc.
I certainly think, customer minutes, reduction in customer minutes lost would be one. I suppose a comparison between the resilience level of the network as a whole, as we mentioned area, and the island would be another. I think beyond that, I would look to our planning team to kind of add to that. But that's based on what I know and what's been discussed. That would be two of the key things, key aspects.
Wonderful. Thank you, Jonathan. Thank you, Stephen. Thank you, Simon. I'll give another hand to all of our speakers in this session today. Thank you all so much.